Hello, everyone, and welcome to the Environmental Finance Center's video, Capital Improvement Planning, Where Do I Begin? My name is AJ Barney, and I am a research engineer with the Southwest Environmental Finance Center. And today, I will be discussing and demonstrating the steps you need to create a simple capital improvement plan. Before we begin, let's briefly describe what a capital improvement plan, or CIP for short, is. A CIP is a plan used to manage the long-term investment in infrastructure and assets that is used by communities, municipalities, businesses, and other organizations. Whether you're a city official, a business leader, or a community advocate, a well-crafted CIP is your roadmap to success. Creating a CIP for a water or wastewater system involves several detailed steps, including assessing your current assets and needs, identifying and prioritizing projects, developing cost estimates and creating project plans and timelines, determining how you will fund these projects, and then implementing those plans. If these steps seem daunting, do not fret. There are plenty of resources out there, including direct technical assistance provided by the Southwest Environmental Finance Center, which we have provided a link for in the description below if you are interested. For this video, we are going to discuss each of these steps, but really focus on creating a priority list for projects based on your asset inventory. We will begin by discussing how to create an asset inventory. An asset inventory is important because it allows you to make sure each asset that makes up your system is accounted for and allows you to evaluate each asset individually. There are a few ways to go about creating an asset inventory, such as specialized computer programs or paper records. But for small systems, we recommend using a simple spreadsheet, such as this small community assistance planning tool, which we will refer to as the SCAP tool for short. The SCAP tool was created by the Eastern Research Group with funding from the EPA and provides simple guidance for systems to catalog and evaluate their systems. Click on the link in the description to download the wastewater or water version. We have also provided a link to the Environmental Finance Center's other resources for using the SCAP tool. For this scenario, we will imagine a small wastewater system that manages their collection system and wastewater treatment plant. The wastewater treatment plant has a screening facility with an aerated grit chamber, primary and secondary clarification, activated sludge, drying beds, and a UV disinfection facility. For this exercise, we have identified 3 assets that we want to evaluate and plug them into our SCAP tool. We already filled the information for the grit removal system, the primary clarifiers, and now we'll complete the critical information for the activated sludge mixers. Based on the asset type, the SCAP tool automatically creates an asset ID for the asset inventory and provides the estimated useful life. So when we select mixer, it generates an estimated useful life, and then after we input the estimated installation date, it automatically calculates the remaining useful life. Location and comments are optional fields, but we'll input some notes here that will be useful for the next tab. For the grit chamber, we have that the pumps fail frequently, the pump manufacturer is now defunct and repairs have to be improvised, and the influence sometimes exceeds design capacity. Then for the primary clarifiers, we have that the clarifiers were refurbished in 2019 and only require scheduled maintenance. For our last asset, the activated sludge mixers, we have that the mixer motors are on a preventative maintenance schedule and basins are drained yearly to inspect mixer blades. Operators have observed moderate vibration from motors and some heat when they are near the motor. We then move on to the condition assessment tab, which autofills the asset category and type and asset description from the information we input from the previous tab. On this tab, we select the current condition of the asset and its reliability to generate a condition assessment score. The condition rating guidance tab here is a useful tool in collaboration with our notes to produce proper condition ratings. If you'll remember from our notes, we indicated that the mixer motors produce some vibration and produce some heat. For other mechanical systems, this correlates with a fair rating. We will go ahead and select no for reliability because we know the mixers only need routine maintenance at this point. The SCAP tool calculates a condition assessment score, and we can move on to our next tab, which is our vulnerability assessment. This tab provides consequence of failure and probability of failure scores, and we've already filled out all the information for our assets, but I would like to point out some of the thoughts that went into this. Now, for this hypothetical system, we decided there is only one grit removal system, but our other assets would have redundancy as there are multiple assets of that type. The aerated grit system would not be considered a regulatory concern, as grit would still likely be removed in our other processes that remove sedimentation, such as our clarifiers. But it would still be a public health and environmental concern because excess grit in the system leads to increased deterioration of other assets that follow it in the system. If you would like to learn more about analyzing assets using the concepts of consequence of failure and probability of failure in the context of asset management, please feel free to reference our asset management resources listed in the description below. Now, the rest of our information mirrors what we had in the notes, and we can move on to our final tab, critical assets. There is no information to input in this tab, which generates a combined condition assessment and criticality score, which determines the recommended priority ranking of our assets we are inventorying. Now, this can either be used as a starting point to rank the assets in our CIP or as a supplementary analysis tool for our CIP. Another simple strategy for determining the priority of our assets is categorizing the assets based on which third of their remaining useful life all or most of their units are in, which for our example may look something like this, where the aerated grit channel and all of its components are considered one asset that is in the last third of its life, and our other two assets we are analyzing may have some of their components in different phases of their life cycle. For this approach, we want to focus the first 5 years, or phase 1, on the assets that are in the last third of their useful life. On first glance, this would indicate that the grit chamber would be the first priority for the CIP. For longer-term CIPs, phase 1 may be up to 15 to 20 years. Another lifespan consideration to think about is different types of assets in your system may have a shorter lifespan than your actual CIP phases. For these types of assets, you may be building in projects that reoccur in each phase and even more than once in a single phase. These types of assets should be evaluated carefully because assets with short useful lifespans and or low costs should possibly be built into your operation and maintenance budget instead of the CIP. Phase 2 spans the next 5 to 10 years and includes assets in the middle third of their useful life, or for CIPs that cover a longer scope, this phase may span up to 15 to 30 years. For this phase, we would consider the assets in the middle third of their useful life, which includes the mixers as potential projects to target. Typically, systems have limited funds and choose to address portions of an asset during different phases. This means that our CIP may recommend replacing or refurbishing some of the mixers during phase 1, but plan to replace a majority in phase 2, and then address the remaining mixers that are in the first third of their life in phase 3. Phase 3 would target the assets in the first third of their useful lifespan, and is usually a more fluid or vague plan. Based on the assets in the first third of their useful life, our CIP may be addressing the remaining mixers as we mentioned, the primary clarifier, and other projects that come along as our system progresses through the CIP. Another important consideration when evaluating larger assets is that they can be broken down into smaller components that would have different useful lifespans. For our example, I am going to demonstrate this with the primary clarifiers. If you'll remember, our notes mentioned that the primary clarifiers were refurbished in 2019, which was 6 years ago. At first glance, this would indicate that the primary clarifiers are in the first third of their useful life. If we evaluate the assets as single assets with an estimated useful life of 20 years. But it's important to take into account 2 factors. The first is that clarifiers have a variety of components composed of different materials that may have different useful lifespans. The second is that we don't know if all of the components were refurbished at that time or just some. So we are going to break down the clarifier into subcategories. And after some digging, it looks like the concrete basin was refurbished and sealed, the scraper was replaced, and a stainless steel dome cover was installed. This means the walkways, baffles, and weirs are all the original parts and in the last third of their life. So using the same method, based on which third of their useful life each asset is in, we would put the walkway, baffles, and weirs in phase 1, the scraper in phase 2, and the clarifier basin and cover in phase 3. Now, these are just two strategies for prioritizing our projects. In reality, we want to use these strategies together along with other priority ranking considerations, such as safety, regulatory requirements, economic impact, community needs, stakeholder requests, funding availability, engineering suggestions, and many others. It's important to consider all these factors and try to avoid bias when prioritizing projects for a CIP. With that in mind, I'm going to start building my priority list based on a couple of these factors, the priority recommendation from our SCAP tool and our useful life assessment. From our useful life assessment, the aerated grit channel, clarifier scraper, drive, walkway, and baffles and weirs are all in the last third of their useful life. Our SCAP tool recommended the aerated grit channel as number 1 on our priority list, but there are other factors to consider. The clarifier walkway is a safety concern, and operator safety should be the number 1 priority for any plant. Since the risk of a failed clarifier walkway can result in a major injury or even death, that will be priority 1 for our CIP. Now I am confident listing the aerated grit channel as priority 2, since our other assets we have listed have redundancy, and replacing the aerated grit channel will protect the rest of the equipment in our system. Number 3 on our priority list will be the scraper drive, since its failure will render the primary clarifier inoperable. The baffles and weirs on a clarifier help their functionality, and if they are dysfunctional, this could result in a regulatory issue, but I would place them behind the scraper drive in our priority list, as they would be easier to address if they suddenly gave out. For our number 5 priority, I would then list the mixers, as they have some redundancy and our notes indicated that they were in fair condition. As the mixers were in a various stages of their useful life, we may elect to address them in a multi-year approach, which gives us some flexibility after phase 1 to address any other concerns that may arise. This is followed by the scraper, which was replaced recently but is still in the middle third of its useful lifespan. After that, we will address the remaining components of the primary clarifiers a little differently. We know that they are both targeted for phase 3 and will likely not have any projects addressing them anytime soon. So we will cross them off together as the last components of the primary clarifiers, and for our final priority out of the assets we evaluated, just set a full inspection of the clarifiers, since we know this component is relatively new and should have plenty of remaining useful life. At this point, we can start to add some general projects that we want to think about down the line, and this can be projects we want to start addressing. This may include things like inspecting the sewers, computer and software upgrades, upgrading to more automated technology, or evaluating and refurbishing some of our other processes, such as the drying beds or UV disinfection systems. Now, the next step in developing our CIP would be to develop cost estimates and project plans for our projects, especially our projects high on the priority list. This is beyond the scope of this video and usually requires the utilization of an engineer or contractor, but we can still fill in some of this information and discuss how to use this information for forming our CIP and future planning. Project plans, such as a preliminary engineering report, will provide an estimated duration for the project, which helps us build a schedule and designate when exactly each project is projected to start and finish. The cost of each project is then essential in planning where financial resources will need to be applied and how other financial plans may need to be adjusted. It's also possible that projects may move up or down the priority list if more planning is needed to secure funds for that project. At this point, our CIP would look like this, indicating the year it is likely to start, the estimated time duration, and total cost for each asset. For our example, we use previous projects that we have worked on to estimate the duration for each project and what they might cost. For developing a simple CIP with just estimated costs, this can be a useful strategy to give you and your stakeholders a ballpark idea of what to expect if specific plans are not available. There are also a variety of tools and resources available for construction cost estimating online, infrastructure plans for other systems to get an idea of what other systems spent on their projects, and unit costs that can be used to create rough project estimates. A well thought out CIP will include project cards or summaries for each project that provides in-depth information about each project. For our CIP, our summary cards include a description of each project, justification for each project, the estimated cost and priority of the projects, which we already discussed, and notes on any priority adjustments that were made. You may also include other data that you feel is valuable to your evaluations. To complete our CIP document and get ready to make it available to stakeholders, community members, and regulatory bodies, we want to build out our document with some additional sections, such as a summary, an introduction, a needs assessment, goals and objectives of the CIP, a financial analysis, an O&M plan and budget, plans for public and stakeholder input, and instructions for revisions to the CIP. We would also want to include a plan to start implementing the CIP, and then that would complete our document. And with that, we are at the end of our video on capital improvement planning. Where do I begin? Thank you for joining us, and I hope you learned something useful from our time. Please check out our other content for all things financial, water, and wastewater. And as always, please feel free to reach out to the Southwest Environmental Finance Center for technical assistance, additional training, or even to help create your own CIP. Thanks again, and we look forward to seeing you next time.